Great, so now we're going to finish up our graphing section with these trig functions by doing the last two here with cosecant and secant. These two graphs are based on their inverse functions, so the cosecant is related to the sine and the secant is related to the cosine. So ultimately we're just going to be graphing those two things. We're going to be graphing the sine and graphing the cosine. And so I need to know a few pieces of information of how they relate. The first thing is when sine of x is equal to 0, and that's when x is 0 and pi. So when I go to the unit circle here, my sine value here is 0. Okay, so sine of theta or sine of x. Same thing over here. My sine of x is equal to 0. And so when I do if I were to say sine of theta is equal to 0 over 1, and then I'm looking for my my other 6 trig functions, and I get to secant, cosecant, I'm going to flip that over, so I get 1 divided by 0. Well, 1 divided by 0 is undefined. I can't do that. And so that's going to create the same situation that we had with tangent and cotangent, where we've got some asymptotes there. And so when I go back here, it's important for me to know that this means I'm going to have an asymptote. Okay, I'm going to find one there. Same thing here. Okay, when I look at cosine, I have cosine is 0 at pi over 2 and 3 pi over 2. So when I flip those over to make secant, I'm going to get it that secant is undefined at those places. And so I'm going to get asymptotes there at pi over 2 and 3 pi over 2. So what do those graphs look like? Well, in order to graph them, you need to have a basic understanding of what the sine graph looks like. So if I'm graphing y equals cosecant x, I'm really going to graph the sine graph of that. So I've got a amplitude of 1, a period of 2 pi. So let's look at that. Here's 2 pi. We start at 0, goes up 1, and down 1. I've got my sine graph in here. It starts here, ends here, crosses here, crosses there, and crosses here. So I've got a nice sine graph here that looks like this. I'm actually going to go back and draw that in as a dashed line, because I don't actually want the sine graph. I'm just using it to help me make the cosecant. I'm going to make one period to the right and then go then to the left. So I've got here's pi, negative pi, and negative 2 pi over here. So crosses and crosses, comes down here, goes up here. And again, I'm going to draw it dashed because I don't want the I don't want the sine graph. The sine graph isn't what I want. The cosecant graph is what I want. But I'm going to make the sine graph in order to get it. So I've got a sine graph here. The cosecant graph is the graph of sine except flipped over. So when I look at this, we look at these 0 points that this crosses the x-axis. When I flip that point over, that's what we were talking about in above when I take when the sine is equal to 0, cosecant is actually undefined. And so when sine is equal to 0, cosecant is undefined. When sine is equal to 0, cosecant is undefined. When sine is equal to 0, cosecant is undefined. Okay? And so look at what happens if I look here. I've got in between each one of these, I've got a nice little curve. Well, I'm going to be flipping those curves over, but I'm not flipping them over the x-axis like a reflection. I'm not putting a negative in there. I'm changing the function itself, so I'm making this an inverse function. And so what I'm actually doing is I'm reflecting upon this point right here. And so that's the graph of cosecant. Here's the graph of cosecant. Here's a graph of cosecant. Here's the graph of cosecant. Right? So I end up with this graph that looks like this. Now this actually, what I have drawn here is 4 different portions of cosecant. It's 2 periods of cosecant, because the cosecant does have a period of 2 pi. And so I've got one to the left here and one to the right here, one period of each of these. So let's take a look at the secant graph. Secant graph is related to the cosine. So let me grab a different color here and make the cosine graph. So cosine has a period of 2 pi. Starts at 1, goes down to -1. It actually starts up there at 1. At 2 pi, it's back up there. In between, it crosses the x-axis and goes down below. Same thing happens over here to the left. I've got -2 pi over here. So when I look at this, I've got the graph comes back down to the x-axis, comes all the way down to the bottom, back to the x-axis, and up to the top of its amplitude. And so I've got a graph that looks like this for my cosine. I'm drawing it in dashed because I don't actually want my cosine graph. I want a secant graph. Well, the same idea, we talked about it above, but the same idea goes here, that if I have a cosine graph and I'm making this the secant of it, every place that the cosine graph is 0, my cosecant is going to be undefined. When cosine is 0, my secant is undefined. When cosine is 0, my secant is undefined. When cosine is 0, my secant is undefined. So then when I go ahead and look at this, I'm looking for the secant graph. So all these little humps that are in between the asymptotes here are going to be become inverses of that cosine, and so they're at these little end points on each of these. And I actually have these end ones look like this. I just kind of cut them off towards the end here, but I have 2 full periods here. I've got one right here. Whoops, right here. And I actually have one between the combination of this and this. And that makes another 1 period. Okay, and so the cosecant and secant graphs are based on sine and cosine. So if you can draw the sine and cosine graph, then all we're doing is creating off the minimum and maximum points of those graphs. All we're doing is creating the secant and cosecant graph. So let's take a look at some of the steps for doing that. Step 1, you have to decide sine and cosine. So you just graph the sine and cosine. We still want to do all of the stuff with amplitude, period, horizontal shifts, and vertical shifts. We want to do all of those things. Okay, so take into account all of those things. We want to do zeros and undefined. Okay, and so when sine is 0, we have an undefined point for our cosecant and secant, and then we're going to draw in those parabolas off of the minimums and maximums. So I'll do one of the problems down below. I'll actually leave this one. I'll fill it in here, but I'll walk through the problems down below here. So there's the graph of cosecant x over 3. Notice that the only thing that really changed was the period. The period in this problem is going to be 6 pi, 2 pi divided by 1/3. And so it really stretched out, and if I were to graph both the sine function and the sine x over 3 function on the graphing calculator, I would see that that one of them is the sine function is pretty small in comparison to the sine x over 3 function. Same thing happens if I were to do the cosecant and the secant. You can graph these on your graphing calculator. The points that you're going to find, though, are more exact if you were to just use that as a checking tool as opposed to the actual way that you go about graphing these. So we've got 3 examples here. The first one, let's get through these. 3 examples. The first one changes, but I look at the first thing that I look for is whether it's a sine or cosine graph. Cosecant is related to sine. Then I'm going to look at the period and the amplitude. The period is 2 pi. There's no number in front of the x. The amplitude is 2. Okay. Horizontal shift, there is none. Vertical shift, there is none. Okay. So this is a pretty nice graph. I've got the sine function starts here at 0, has a period of 2 pi. Halfway in between is pi, and then we've got those 2 values that are halfway in between there. I've got an amplitude of 2, so it goes up 2 and down 2. The sine function looks like this. But I don't want the sine function, so I'm going to draw it in as a dashed graph. I need to draw in asymptotes at places that x is equal to 0, or this graph is equal to 0. And then I'm going to actually draw in my cosecant graph. So my cosecant graph is going to look like this. And that's one full period of the cosecant graph. You can go ahead and put that same information to the left, but I want you to be able to do at least one full period correctly. The next one, so I've got secant, which is cosine. I want to look at the period. The period is equal to 2 pi divided by 2, which is pi. Since I'm over here, there is no horizontal shift and there is no vertical shift. The other thing that I want is the amplitude, which is the absolute value of -3, which is 3. So this is going to go up 3 and down 3, and it's going to start down here. I'm going to put that point there because it's got that negative in front, reflects. So that's going to hopefully help me remember. It's one of the things that I forget as I go through here. The period is not 2 pi. The period was pi. So halfway in between 0 and pi is pi over 2. And then we want these values in between. You don't need to figure them out, but add the 2 ends together and divide by 2. We'll figure them out for you. The cosine graph is going to start down here. It's going to cross, and then it's going to go up to the top. It's going to cross, and it's going to come down. So this is going to look like this. Okay. Now, when I look at that, it looks like there's only one top or one maximum in this. And so I kind of want to go to the left a little bit here so that I can see exactly what's actually happening with this secant graph, with this secant graph that continues over here. So this goes over here and then comes up to the top again. Now I actually can see that I have a minimum and a maximum. I have them in the other side, but you'll see here in a second what happens with those. So it's a better graph if I go to the left a little bit. Some asymptotes. When cosine is equal to 0, I get asymptotes here. And then I'm going to draw in my secant graph at the minimums and maximums. So there's a maximum there, there's a minimum here. There's a minimum here, but I really only showed the left side of that. And there's a maximum here, but I really only showed the right-hand side of that. Okay, and so it's a better graph if I have if I can see 2 full sections of those parabolas. But if you had the 2 halves, that's also correct. Don't forget to put the 2 halves in, though. If you're going to stop and not put the whole thing in there, you got to put those halves in there. This one, I've got y equals secant, so I'm looking at a cosine graph. I've got a period equal to 2 pi. I've got an amplitude equal to absolute value of -1, which is 1. And I've got a horizontal shift in this one. So if you understand the idea of phase shift, we're just shifting everything pi units to the left, so everything moves pi units to the left. If you were having trouble with that, remember that we did the start point was set that equal to 0. So I get x equals negative pi, and the endpoint was set that equal to 2 pi. Subtracting pi from both sides, I get my other ending point, or my ending point at 1 pi. So I start at negative 1 pi and end at 1 pi. That's my phase shift in here. So I'm starting over here at negative pi. I'm ending at 1 pi. I'm going to put an extra function in here to go to 2 pi. And that's not far enough over. Here's going to be 2 pi. And so I've got all my values here in between these to make a good secant graph. The amplitude was 1, but my graph for my cosine is going to start down here at negative 1 because I have that negative in front. We've got a period of 2 pi, so this graph is going to exist in make one full revolution in 2 pi, but I just shifted everything to the left. So I actually am not starting here. I'm starting here because I hadn't shifted it yet. So now I shifted it. So this graph's going to go up to the x-axis, up to the top of the amplitude, back to the axis, down to the bottom of the amplitude, back to the axis, up to the top of the amplitude, axis, and back down again. And so there's my cosine graph. Looks like this. Okay, so my cosine graph is going to look like that. I don't necessarily want the cosine graph. I want the secant graph. I'm just using the cosine to help me find it. So I'm going to draw in these asymptotes where the cosine graph was equal to 0. Then I'm going to go to my minimums and maximums and add these parabolas on them. So the part in red here is the actual secant graph. The part in blue doesn't actually exist in this graph. So if you were to graph this on a graphing calculator and try to get rid of this without erasing too much of my graph, if you were to graph this on a graphing calculator, this is what you should end up with. Negative pi was there. And then we had 2 pi over here. And we had 1 pi over here. Okay, so if you actually were to graph this on a graphing calculator, this is what you're going to see. They're not going to put the cosine graph in there. The cosine graph isn't truly part of my graph. The cosine graph is actually just a way to help me to create the secant. So the secant is only these parts that are on the minimum, attached to the minimum or maximum of the sine or cosine. So take a second, make sure that you're doing these graphs. If you're not doing the graphs, you're not going to get it. You can watch it, and you can sit there and understand that what I'm doing this whole time, but you need to do the graphs in order to get the graphs. And please do the graphs.